In this video, we're going to look at a very unusual reaction called ozonolysis. It's a destructive reaction. It tears molecules apart. Why? Because ozone, which is O3, a second allotrope of oxygen, is a very reactive molecule. You make ozone from O2 by putting O2 through an electrical discharge. This gives you O3, and as you might expect, O3 is a really powerful oxidizing agent, enough to oxidize double bonds all the way to carbonyls. So how does this work? Well, the double bond will attack the one oxygen, move this electrons over, and then this lone pair comes down, attacks the carbon there, and what we're going to form is a cyclic compound. This cyclic compound is a very reactive species. It wants to fall apart. You can imagine 3 oxygens in a row is very unstable. So what happens? Well, we actually break the carbon-carbon bond, form a carbonyl. Okay, this carbonyl then kicks out this oxygen. Okay, and to make up for the fact that we lost electrons there, this comes down and forms a double bond. So this gives us 2 separate molecules. One of them is this very, very sensible-looking carbonyl compound, but the other one is this weird-looking species here. Now, this weird-looking species here is obviously very reactive, and indeed it'll turn around and just react with the carbonyl that it just made. But the interesting thing is it does it in a different way. So let me just move these molecules a little bit. Is that this originally oxygen was bound to this oxygen, but it turns out, of course, that's kind of wrong, because it's much more stable for the oxygen here to attack the positive end of the carbonyl, which is the oxygen. And then this carbonyl can come and attack this carbon, and then this double bond moves over to form that oxygen. You draw that arrow out, hit the magic button, we get this new ring, which still looks pretty weird, but it's better than the original one. Now we only have 2 oxygens in a row and not 1. So this all happens at once. No intervention. Is a fast reaction. But now we want these things you can actually isolate, but we actually don't want to isolate it. We want to tear it apart again, and the way we do that is we use dimethyl sulfide. Why dimethyl sulfide? Well, dimethyl sulfide will pull an oxygen out of the molecule. And so how does it do that? Well, it attacks an oxygen like this. Okay, this will cause this to break this bond, goes over, forms a carbonyl there. This then goes and forms a carbonyl there, and then this bond gets kicked out back to adding electrons to that same oxygen. So what's this going to give us is it gives you an aldehyde, and it gives you a dimethyl sulfoxide. Now, this aldehyde here, well, I was going to do one of them, but of course there's 2 of these because going to get from each side. If way back here we had an ethyl group on there, we would have an extra methyl. Sorry, we'd have an extra methyl all the way along here. We'd have an ethyl here. One of these would have an ethyl, okay, and one of these would have an ethyl. I may be putting on the wrong side. I'm not paying attention. And then down here, one of these, of course, would have an ethyl. So the net reaction is you take your alkene, you basically tear it apart. Both double bonds, carbon-carbon, both sides of the carbon-carbon double bond becomes a carbon-oxygen double bond. Now, if this group had another substituent, what you'd make down here is a ketone. So this is really a destructive reaction, and it's sometimes used in synthesis, but more commonly we use this to evaluate molecules, to try to help figure out what they are. So we'll do some examples of that in the problems.